All right, this is the quick review, so I got to go kind of fast. Properties of logarithms. Remember, logarithms are exponents. So this is an exponent, and this is an exponent. And what's the rule? X to the a times x to the b equals x to the a plus b. That's why you add the logarithms. All right, that's the tie-in. If you look at my full lesson, I explain that more fully. But here we've got log subscript 7 base 7 to n. So if I wanted to, and again, this is a means to an end, I could split this up into log base 7 2 plus the log base 7n. Now this would help me if I was trying to solve an equation because it would allow me to try to isolate the variable, right? And this is a number. Remember we already learned last lesson how to find the value doing the change of base formula? This is the log of 2 divided by the log of 7. So I can go ahead and solve this equation now if I split it, right? So there's means to an end. You'll learn that later on in the lesson. All right, second rule. What about division? Well, you subtract. What's the tie-in? X to the a divided by x to the b equals x to the a minus b. So we subtract. So again, you got something like this. Hey, I can do two rules on the top, right? And by the way, common log or natural log, it doesn't matter. So I can do natural log of 3 plus the natural log of x. See how I split up the 3 and the x on the top? That's the first rule. And now I'll use the second rule. Divide it by the natural log of the 5. All right? It's just means of manipulating logarithms so we can do some other things in the future like solve them. All right, what about this one? Real important, the power rule. So what it's basically saying is if the result has an exponent, you can put it out in front of the logarithm. Very valuable. Very valuable. It's going to really help solve a lot of logarithmic equations. So something like this. All right, see where the variable is? It's an exponent. So I have the right, whoops, sorry about that. I have the right to take this 3n and make it a multiplier in front. And now the rest, look, this is just a number. I could easily solve this equation for n. You know what? I might as well do it because this is the means to the end. All right, things multiplied times the variable. How do you move them? You move them by multiplying times the reciprocal. This is multiplied times the variable, and this is multiplied times the variable. So all I have to do is divide this by that, right? Log 312. You might say, well, what's log 312? Okay, remember the change of base formula? It's the natural log of 12 divided by the natural log of 3. So what are you doing? Taking 30 and divide it by 3 times the natural log of 12 divided by the natural log of 3. Boom. You just solved that logarithmic equation. Awesome. That's fun. All right, and then the last rule here. Just a concept here. If log bx equals log by, then x equals y. The exponents are equal. All right, so let me show you this one. So it's just a simplistic thing. What's the base in both of these? And that's the key. The bases have to match. Here the bases are b, and they match, and therefore x equals y. In this one, the bases are e, right? And they match. So guess what? 2n equals 68. And what's the value then? 34, right? Piece of cake. So again, and this could be in any different, it could be the log base 7 2 equals the log base 7 of x. So what do you get? 2 equals x. All right, and that's how you use that rule. Properties of logarithms. Learn all 4, and they'll really help you go a long way in solving logarithmic equations and finding values of logarithms.